Hi, I'm Adam. Welcome back to Godot Game Lab. In this episode, we'll do a bunch of really cool stuff, and this is probably one of the hardest episodes yet. So make sure to buckle up, take breaks if you need to, because this is going to be a long ride. Right, so what are we doing here? We'll create the new Modifier System, which works like this. If I play this card, which says deal 4 damage and apply to exposed, I can use this on the crab enemy, and you can see that it has this 2x under it, just like it did before, right? That's already done in the previous episode. So what's new? First of all, I can click on the statuses now, and we get this status tooltip view where we can actually see an explanation what they do. So it says that it takes 50% more damage for 2 turns. Pretty cool. So if we go back, you can see that I can play my basic deal 6 damage card, right? So if I click and hover this and target the enemy, you can see that the tooltip will live update its damage to 9 instead of 6. And if I move the cursor away from the enemy, it goes back to 6. Pretty cool, right? And indeed, if I play the card, it will receive 9 damage. How cool is that? And you can see that I have the same exposed applied to me for now. And if I end my turn here, and the enemy intends to attack, what's interesting is that by default, this crab enemy deals 7 damage, right? But since I have that exposed status on me, it updated to 10. So if I play 2 block cards here, you'll see that it removes all the block from me. What about this power we had before? So if I play this one, I'll get a new status effect. And if I click on it, it says at the start of its turn gains 2 muscle. Okay, so let's end my turn here. And you can see that I gain 2 muscle. So far so good, right? And if I click on this, it says muscle attacks deal 2 more damage. And indeed, if I hover over my cards here, you can see that instead of the 6 it had before, this basic attack card now says deal 8 damage. My AoE cards, which deal 4 by default, are updated to 6. Pretty cool. So if I end my turn again, you can see a couple of things. First of all, the crab will revert back to its 7 damage because I no longer have the exposed status. So all the enemy intents now can react to the gameplay and update dynamically. Also, if I hover over my card here, it now says deal 10 damage because my muscle is updated to 4. The status description we have here is dynamic as well because it said 2 before, but now it's updated to 4. Now, if I use my card here, indeed I deal 10 damage. Right, if I end my turn here, I take 7, my muscle is updated and I deal 6 more damage now. So in this case, my AoE attack becomes 10 damage because 4 plus 6 is 10. Okay, so if I play this and win the battle, then I become victorious and I can draft a new card. Okay, but what about here though, right? Because this description doesn't have to be dynamic. So if I click on this one, it says deal 4 damage and apply to exposed. So what I mean by that is providing this tooltip is different from what we use in the battle. So if I play another battle and play my whichever card I want to, let's play the power card. Again, you can see that my cards start to become stronger and stronger. Instead of 4 damage and 2 exposed, this is now 6 damage and 2 exposed. And if I play this, it removed all the block this enemy has. I have all the statuses now on me. And the enemy has its own statuses. Right, so if I end my turn here, one pretty cool thing is that these effects and modifiers can stack on top of each other. So you see I have 4 muscle now, which means I deal 4 more damage, right? And indeed I do. If I start to play this single attack card, it says that I deal 10 damage, which adds up because 6 plus 4 is 10. But this enemy still has exposed, right? So if I hover over it, it should take 50% more damage. And it says that it will deal 15 damage if I hover over that enemy. And if I do, boom, I do 15 damage. However, in the case of the draw pile, the discard pile, or the deck view, these card descriptions shouldn't be concerned with the modifiers we currently have in the battle because they are independent of the battle, right? I can view my deck in the map as well. So if I click on these, it will still say that they deal 6 damage, even though we can see that if I hover over it in the game, the amount will be different, right? So if I end the battle here, say I do 18 damage, I scaled up pretty hard, I'm victorious, I can take a new card or skip it. And here I can also view my deck, right? And in this case, it still works, It doesn't break because of the modifiers which are present in game. So this is what we'll do in this video. I hope you're excited, so let's get started. Before we start coding, let's discuss architecture first. The biggest task of this episode is to create a brand new modifier system. Here's how it works. On the top, we have the ModifierHandler, which manages all the modifiers attached to that individual. Under that, we have modifiers. Each modifier can be used to modify a specific type of numeric value or values in the game. For example, the damage dealt modifier adds changes to the damage dealt by that individual when using attacks. The calculation of the resulting value is based on modifier values. These values are either flat values like +3 or -2, or percentages like +50% or +20%. Also, modifier values need to have a source ID so we know where this value comes from. With this technique, different status effects, relics and cards can apply modifications independently from each other, which makes the system flexible and easy to use. Also, all of these different components will be nodes in our scene tree. Why? What's the advantage of doing that? Well, using nodes in this case means that we can edit our modifiers or modifier values in runtime, meaning that it's super easy to change things, add or remove modifier values, or even modifiers during battle. Super convenient. Let's see an example how we can use this in-game. Let's say we have our hero and we play a card which would deal 10 damage to our enemy. However, both our player character and the enemy have some modifiers because of some status effects, relics, or whatnot. In the case of the hero, we have two values for the damage dealt modifier. A +3 flat value and a +50% value. For the enemy's damage taken modifier, we have a -2 flat value and a +20% value. The calculation algorithm applies all the flat values to the base value first, then adds all the percentages to the base 100%. Our damage will be 10 base damage plus 3 flat damage, which is 13, multiplied by 1.5 to get that 150%, resulting in 19.5. To make sure that we only have integer values in the game, we floor this to 19, which is our modified damage. Then we can call the enemy's take damage method with 19 damage, right? But we also apply the damage taken modifier values to that before actually taking that damage. Again, we start with the flat values. 19 minus 2 is 17. Then 17 times 1.2 is 20.4. Flooring this to an integer means that the enemy will take 20 damage with all of the modifiers applied. Pretty cool, huh? Mind you that the modifier itself doesn't care about what that number is used for. It is only a means or an interface with which we can calculate the resulting number, but actually dealing the damage is the responsibility of the damage effect class. Similarly, taking damage is implemented separately both for the enemies and the player. The modifier system or the modifier handler doesn't really care about that. It's just there to make the calculations for us. So, to make sure that the modifier system is flexible and independent, we only use it to perform these calculations, then return that integer value. Implementing the modifier system in itself isn't that complicated. However, it introduces the problem of magic numbers, as they call them in Slay the Spire's source code. So, what are magic numbers? When we display a tooltip, we want to show the damage the card will do, right? The problem is, it's not that simple anymore. What if the player has active modifiers? What if the targeted enemy has a modifier? What if both of them do? We need to handle all these cases. At the same time, this only applies in the context of a battle. So we also need to provide the sort of default tooltip, because when we display tooltips in the deck view, or when getting card rewards at the end of the battle, we actually don't want to look for any modifiers, right? So a big part of the video will be dedicated to adapting the card tooltip system to meet these new requirements. This is a pretty big refactor, as a lot of existing scripts and scenes will be modified. The card UI, the card state machine's base state, the card resource, the specific card scripts, etc. The same thing is true for enemy intents. We can't just display that the bat deals 2 times 4 damage as a string anymore, because what if that bat is buffed? What if the player has a debuff which makes them take more damage? It's not just a rigid static number anymore. On top of these modifications, we also introduce status tooltips. So when you click on a status handler below the player or one of the enemies, you can see what statuses they currently have and what each of them do. These tooltips can also have a magic number similar to what we just discussed. So since status tooltips are kind of a new addition to the game, let's see what kind of new things we need for those to work. So we'll have a new scene called status tooltip, which displays the tooltip text and icon for one status resource. This scene will be instantiated by the status view scene, which is also a new scene, and it is kind of like a pop-up window that's available in the battle scene. We also need all the status handlers inside the battle scene, so whenever we click on them, we pass the current array of status resources to the status view, which then instantiates a status tooltip for each of those statuses. So we also need to establish this communication line between the status handlers and the status view. Pretty cool, right? So let's get started. With the project open, we can start building our modifier system. And just like we usually do, we go from the bottom upwards, so we have all the prerequisite things implemented before doing the highest level stuff. In this case, we need to start with the modifier value because this is the lowest we can get in this new system. So for the modifier value, we want to create a new scene for. So let's click on this plus sign to add a new scene. We use another node as a root node, and we just need to use the basic white node as our root node here. So click on create or press enter, double click and rename this to ModifierValue. Let's not forget to save this because this is unsaved. So press Ctrl S, go to scenes folder here, and we can create a whole new folder for the modifier stuff. So we can press create folder, type in something like ModifierHandler, and we can put ModifierValue.tsc into this folder too. So press save. And to actually make this node do something, we need to attach a script to this. So click on attach a script. ModifierValue.gd is perfectly fine, but we don't actually want to use the status effect template for this one. Instead, we can use object empty. Press create, and let's see what we need to do here. So again, just a quick recap, the modifier value itself is responsible for actually storing a specific number we want to apply as a modifier, right? So these modifier value nodes will be children of modifiers which modify one specific thing of an individual. For example, we have damage dealt modifier or damage taken modifier. And under each of these modifiers, we can have modifier values, which are either flat numbers or percentages. And one thing we also need to make sure of is we use an ID to track where that number comes from. Why do we need this? Well, let's take muscle as an example, right? So muscle will be a status which stacks up, and the more stacks you have, the more damage you deal based on that flat value, right? So when we add a new modifier, we don't have to add it over and over and over again. Instead, we can just sort of check if we have a modifier value with that specific ID, in this case muscle, and if we do, we can just overwrite it, right? So for each of these modifier values, these numbers, we know their source, we know where it comes from, and we can do whatever logic we want to do with it. So how do we do this? First, we'll provide a custom class name called ModifierValue. Then we have an enum, which is either % based or flat. And then we have a couple of export variables. We need to set the type for each modifier value. Then we can assign a percentage value to it, which is a floating point number, and the flat value, which is an integer. And also we have that source ID, which I just talked about. And in this case, I actually use the static function, which I'll explain in a sec. This function is called create new modifier, and it has two parameters. One is the source ID, and one is that type enum value, indicating whether we want a new % modifier or a flat one. And this static function returns a modifier value instance. So inside this function, what we do is we create a new modifier value instance, and we set the source and the type to whatever we passed on as a parameter to the function, and return that new modifier instance. So why do we use a static function here, and what this method will be used for? Well, it's again a new addition to the GD script language that we can have static functions, and for static functions, we don't actually have to create a modifier value instance in the scene tree. Instead, we can use the class name and say that we want to call ModifierValue.create new modifier. And with this technique, whenever we want to create a new modifier from code in runtime, we can just, instead of having to reference a constant to this scene we just created over and over again and setting these values over and over again, we can sort of wrap up this functionality inside this nice little static function. And we just need to call this, and we know that this will return a new modifier, which we can use however we like to. This is super useful because when we want to create new modifiers during runtime, we'll have an easy method to do it, and we don't have to repeat this code over and over again. We just pass in the parameters we want to, and we know that we always get a fresh new modifier value node, which we can actually add to a modifier in runtime. Hopefully that makes sense, but we'll see it in action in just a sec. So that's all the code we need for the modifier value, and we can save this with Ctrl S. With that done, let's go back to 2D view and again create a new scene, this time for the modifiers. Click on the plus sign, go to other node, add the node as a root node, double click on this and rename this to modifier. Let's not forget to save this with Ctrl S as modifier.tscn, and we can attach a script to the modifier node itself too. So click on the attach script, modifier.gd is perfectly fine. And object empty is the template we want in this case. So press create and let's see what we do here. So the modifier class itself is responsible for managing one specific modifier, for example, a damage dealt or a damage taken modifier, right? So again, we'll start by providing a custom class name. This time we'll call it modifier. Then we'll have an enum, which basically enumerates all the possible modifiers which are available in the game. For this project or this example, I will implement 4 different modifiers in the course of the whole season, namely damage dealt, damage taken, card cost, shop cost, and no modifier, which is used as sort of like an indicator saying that this is not a modified value. Why we need this is something we'll circle back to later on. And for now, let's just deal with the other ones, right? So all these modifier nodes will have an export variable with this type enum, so we can set the type of this modifier from the inspector. Then we'll need a bunch of methods, the first of which we'll call getValue, and it takes a source ID as a parameter and returns a modifier value. And what we do is pretty simple. We iterate through all the children we have as modifier nodes, and we know that their children will be modifier value nodes or instances. So we can check if the current children's source is equal to the source we're looking for. If that's the case, then we found that modifier value and we can return it. But if we loop through all the children and we don't have a match, this means that we don't have a modifier value with that specific ID and we can return null. Then we have a really useful method called addNewValue, which takes a modifier value node as a parameter and adds it under itself. So how does that work? First, we need to check if we have that modifier value or not. So we'll grab it with this getValue method we just created. And if it's null, then we can just sort of add it as a new child because we didn't have it yet. However, if we already had that modifier value based on the source ID, then we can just sort of override the flat value and the percent value that this parameter has. And that's the case when you had like 2 muscles before, right? Then your modifier value with the muscle ID would be 2. But then you get another 2 muscles, right? Another 2 stacks. So then you have 4 stacks of muscle. If that's the case, you try to add it again with the muscle ID, but this time the flat value will be 4 instead of 2. And if that's the case, we grab the current reference to that muscle modifier value. And since we found it, we can just sort of replace the old values, right, with the new ones. So we override that 2 flat value we had before with 4. And that's perfect. So this is how we can add new values with those 2 cases. Either we had it before or we didn't. Both cases are handled by this method. Then we have sort of the counterpart of that, which is the remove value. And what we do is pretty simple. We iterate through all the children as modifier values. And if we found the value with the source matching, then we can just queue free it. And that's sort of one of the big reasons why this system is so powerful, because if we use nodes, we can just modify them like that in runtime, right? When the game is running. pretty cool because the only thing we need to do when we want to remove a modifier value is just to delete that one. Pretty simple. And we also provide a method for clearing all the values whenever we want to reset them for some reason. And that's pretty simple. We don't even have to check for anything with an if statement. We can just loop through all the children or the modifier values and queue free all of them. And the last method we need to implement is probably the most interesting one, which is that getModifiedValue method. It returns an integer and it takes an integer as a parameter as well, which we call base. So what does this method do? It's basically the calculation logic, the algorithm we use, which we just discussed in the architecture overview. So this is how we can get the value based on the modifier values we have. First of all, the flat result will start from the base value we have. This is why we have that parameter called base. And we also have a base percentage result, which is 1.0 by default, meaning 100%, right? So we start from the base value with a 100% multiplier. Then what we do is we apply all the flat modifiers first. So we iterate through all the children and sort of filter through them for only the flat type modifier values. And when we found one, we sort of just add it to the flat result by referring to that modifier value's flat value property. And when we're done with all of that, then we can move on to the percentage based ones. And in this case, we kind of do the same, but we filter for percentage based modifier values and we just add them to the percent result. And when we're finished with all of those calculations, then we call floor I, which stands for floor integer, to make sure that we end up with an integer value, and take the flat result. We have the accumulated flat result and multiply that by the percent result we have. And with this calculation or system in place, when we actually don't have modifiers, we'll just use the flat result, which is the base one. Let's say that's 6. And we don't have anything added to the percent either, right? Because we don't have modifiers. Then this will be just 6 times 1.0, which is 6. Perfect. So this algorithm always works. It works when we only have flat type of modifiers. It works when we only have percentage-based modifiers. It works when we have both. And it also works when we have neither. So one limitation of this algorithm is we can really implement a card, for example, which guarantees you to do like 0 damage, for example, right? And that's because you could say that you like add a percent modifier with -1, right? So then you have the percent result at 1 and you add -1 to that and you end up with 0, right? Well, that's kind of true, but at the same time, you only get that 0 result you want if there are no other percent modifiers. See the problem here? So this is one like known limitation of this technique. So if that's what you're going for, you might have to rethink that algorithm. But otherwise, I think it's a good trade-off because it's pretty simple and you can do a lot of cool stuff with it, a lot of synergies, right? Because you can like apply percentage and flat modifiers too. Even if you want to do something like a 0 damage turn, you could sort of get around that limitation by applying a -999 flat or something like that to make sure that the player almost always ends up doing 0 damage, right? So I think this is a pretty good solution, but again, you can experiment with this method itself however you want to. This is just one solution I kind of like, and I ended up opting for this one. Right. So that's all we need for the modifier class itself. It's pretty simple. This is like the most important part of it, actually calculating the resulting value based on a base value and then applying all the different kind of modifier value children's numbers. Cool. So let's save this with Control S. And with that done, the final thing or the final piece of the puzzle we need to do is the top part, right? The modifier handler, the highest level node. So let's go back to 2D view. One more time, click on the plus sign, click on other nodes and use a node as a base here as well. Double click on this and rename this to modifier handler. Press Ctrl S to save this. Modifier handler.tscn is perfectly fine. Click on save and attach a new script to this. Object empty as a template is absolutely brilliant. And let's go with modifier handler.gd. Press create and see what we need to do here. Right, so first things first, we need a custom class name and we'll call this ModifierHandler. Then we need a bunch of methods we can use when we deal with modifiers. So one of those is hasModifier, which is a Boolean method. It returns a Boolean value and it has one parameter, a type of modifier we want to check if that individual has it or not. So how do we do this? Well, we know that for ModifierHandler nodes, all their children are modifier nodes. So what we can do is we iterate through all of them and check if their type export property matches the type we are looking for. If it does match, we can return true, but if we iterated through all of them and there were no matches, we can return false. In a similar fashion, we have a getModifier method with the same parameter, but instead of a Boolean value, it returns the modifier node itself. So the method is roughly the same. We iterate through all the modifier children, we check for the type, but instead of returning a Boolean, we return a reference to that node, or if the node isn't present, then we can just return null. And we also need this getModifiedValue method, which is probably the most important one in terms of actually implementing the logic we want to, for example, for damaging people, right? So when we want to calculate these modified values for doing or taking damage, we can reference the individuals, the players or the enemy's modifier handler, and just call this method to let the handler do its thing. So for getting a modified value, we need a base number, which is an integer, and we need a modifier type, so we can grab the modifier we want to. And then we just return an integer value from this with the modified value we calculated. So how do we do this? First of all, we need to grab the modifier based on the type we provided for this function call, right? We just did the method for that, so we store that modifier reference in a variable. If it's null, then what it means is that we don't have this type of modifier, right? So if I were to, for whatever reason, grab the card cost modifier from an enemy, I'll never have that, right? Because it makes no sense to attach a card cost modifier to an enemy, because card cost is related to the player. So if we don't find that specific modifier we're looking for, we just return the base number because we can be sure that there will be no modifications applied to it. But if the modifier reference is not null, then we know that we have that specific type of modifier. So we can just grab the reference to the modifier and call that getModifiedValue function we just provided, which will again apply the flat values first, then the percentage values. Then we multiply those, floor them to an integer, and get that value. And that's it. Our modifier system is basically done. We can save this with Control S. The next big question is, how do we actually use this, right? Because right now, even though we created it, we kind of have to hook this up, but also we need to modify a bunch of stuff in the project to make sure that all the other systems will use this modifier system. So that's what we'll do next. So it would be pretty useful to know if this system is working or not, right? But it's kind of hard to test it without hooking it up first. So let's play around with the muscle status we have, because muscle would be a pretty cool way to test this. First of all, let's go back to 2D view. And for the muscle to work, we need to make sure that we hook up this modifier system with the player. So let's press Ctrl+Shift-O and search for player.tscn. And you see that we have no modifier handler attached to the player yet. So select the player as the root node, click on the instantiate child scene or press Ctrl+Shift-A and search for ModifierHandler.tscn, which we just created. Okay, so now we do have a modifier handler. What's next? Well, if you remember, modifier handlers will have modifier nodes as children. So we know what kind of modifiers we want to keep track of for this individual, in this case, the player. So with the modifier handler selected, let's click on the instantiate child scene button again, or press Ctrl+Shift-A and search for modifier.tscn this time. And if we add this, you can see that it's called modifier. We'll rename this in a second, but you can see that we actually have an export variable for the type this time, and we can choose between all the available modifiers we declared in that enum. So for the player, we'll have 3 modifiers. So we can select this modifier node we just added and press Ctrl+D 2 times. And let's rename those one by one. So the first one we'll call damage dealt modifier. The second one we'll call damage taken modifier. and we can delete that 2 at the end. And the last one we'll call card cost modifier, like so. Okay, so these are pretty nice, but let's not forget to actually change those types, right? These enums. So for the damage taken, this will be damage taken instead of damage dealt. For the damage dealt, the first one is perfectly fine. And for the card cost, we'll change this to card cost modifier type. Cool. So that's all the setup we need from the inspector side. Let's see if you need to change anything for the player's script itself. So let's click on the script icon next to the player and see what we need to change here. Surprisingly enough, for now, we only need to change one line of code really. So we have our onReady variables here, and we actually want to have another one for the modifier handler, so we can access this from code, right? Whenever we need to. And the player itself doesn't have to do anything with the modifier handler, because this will be the responsibility of whoever wants to access those modifiers or change them, right? It's not the player's visual representation node's responsibility to do so. We just sort of provide an interface, a tool for all the other parts of the game to use these modifiers. So let's save this with Ctrl S, and let's think about this for a second. So where do we want to actually use those modifiers? Where do we want to change them? How do we want to change them? Those are the questions, because yeah, we hooked it up, but we still can't test it, right? And we said that we want to test it with a muscle. Maybe we can do something with the muscle itself, right? So let's press Ctrl-Alt-O and search for muscle. And we only have one script for the status itself called muscle.gd. And so far, what we do is we have this initialize status method. And when the status effect changes, we print out this debug message saying that we have X amount of stacks of muscle, but it actually does nothing. So let's see how we can change this with our new modifier system. So we can change both of those functions to make sure that we use that new modifier system. First of all, for the initialize status, connecting to the status changed signal is perfectly fine, but we actually need to pass the target node as an extra parameter to that callback function. So what we do is we bind it when we connect this method to the status changed signal. So why do we need to access the target node? Let's think about this for a second. The muscle will be attached to either the player in this case, or we can imagine that in the future there will be enemies who can gain muscle as well. Doesn't really matter though. Either way, the target for the status is the owner, right? So if I'm the player and I own that muscle, the target will be the player node. Which is cool, because if I have access to the target to the player node in this case, it means that I also have access to that brand new modifier handler node as well, right? That's why we made that onReady variable reference. So let's see what we can do on that onStatusChanged callback instead of just printing out a debug message. So first of all, we'll use the assert function for making sure that the target has a modifier handler. And how assert works is it evaluates the first argument expression. In this case, we want to grab the target's modifier handler property. And if it's true, the result of the Boolean expression is true, then nothing happens, the method continues the execution. But if it's false, it will raise an error message, and the error message will be the second argument, right? So we just want to make sure when the game crashes, we see like a reasonable message which helps us debug the game faster. So if there's no modifier handler on the target of that muscle status, we can just print out that there are no modifiers on that target. Awesome. But if we do have a modifier handler, like we do in the case of the player, then we can actually grab a reference to the damage dealt modifier, because muscle itself will have to do with the damage dealt modifier, not with the other ones. So what we do is we call the modifier handler's get modifier method, and we pass in that enum value saying that we want the damage dealt modifier, right? Again, we store that reference, that modifier reference in a variable, and we can use another assert statement to make sure that the target doesn't just have the modifier handler, but it also has a specific damage dealt modifier, right? Because for muscle to work, whatever target we use it on, it needs to have a damage dealt modifier, right? So we check for this to exist with the assert statement, and if it does, then we can actually check for the muscle modifier value based on that source ID. So what we do is we ask the damage dealt modifier, hey, do you have any values which modify the damage dealt by this entity based on this muscle source ID? Because if you don't, that means we actually have to create a new modifier and attach it to it, right? Because there was no other muscle-based modifier value attached. So if we don't have a muscle modifier value, then we can create a new one. And this is where that static function we created comes in handy. You can see that we type in modifier value as the class name dot create new modifier. So if I control click on this and we go back to that definition for a second, I don't have to do this, right? Because in muscle.gd, I could do something like this. I could say modifier value.new, set the source, set the type to whatever I like, use these values. But I have to do this every time for whenever a status, a relic, or a card wants to create a modifier. And instead of repeating this process over and over again, we just created a static function so we can call this from whenever. It's pretty similar to calling a method in an auto load, but you don't actually have to create it as an auto load with the static keyword in Godot 4. You just need to access the class name and call that method you want to, right? Either way, at this point, we have the muscle modifier value, either because we created a new one or because we already had one and just sort of grabbed it from the damage dealt modifier. And it doesn't really matter because if it's a new one, we want to set its flat value to the amount of stacks we had. But if we already had it and it's not a new one, we want to override it anyways, right? So it doesn't really matter how we end up with the muscle modifier. If it's a new one, we assign its flat value to the amount of stacks we have. But if it's the old one, we override it anyways. And when we're finished with the muscle modifier value, we actually want to add it to the damage dealt modifier with the add new value method. At this point, this must be a bit confusing because we have 3 different classes with different methods and they are really interconnected with each other and we reference a bunch of them. So if it's confusing, I suggest you pause the video and scroll back when we implemented those bits one by one and hopefully it will make sense what we do here. Anyways, that's all we need for the muscle to work really. So hopefully now you see what kind of flexibility this system gives us. The whole thing we want to do, like adding to the damage of the player or the enemy or whoever possesses that muscle status, is contained inside the code of that class. So the concerns of this muscle status and the modifier or the whole status effect system really are separated from each other. And if I want to change something for the muscle itself, I can be sure that the code I need to change will be found inside muscle.gd. And I'm super proud of this modifier system. I think, at least to my abilities, I came up with the best solution I can to make it flexible and independent from other parts of the game. And I really, really like how it turned out. So with all these new code, we can save the game with Control S. And now we are able to test this, actually. So let's run the game and go into a new battle. Perfect. In my first turn, I draw the power card, which we did earlier. And let's go back to the editor for a second and open up the remote scene tree to see what's going on better. Under run, we'll have current view. We'll have a battle inside that current view. And you can see that under our player node, we have our new modifier handler and we have our 3 modifiers here. The damage dealt, the damage taken, and the card cost modifiers. However, you can also see that the damage dealt modifier is currently empty as it has 0 children, right? So let's go back to the battle and play that power card, even if it means taking some damage. So if I end my turn here, the bat attacks me. And at the start of my turn, I gain 2 stacks of muscle, right? So what's going on here inside the scene tree? You can see that I have this little arrow next to the damage dealt modifier. And what's that? Oh, that's a new node here. So if I click on this one, you can see that I have a new modifier which will have type of 1, which means that it's a flat value, not a percent-based one, because if I go back to ModifierValue.gd, this will be 0 and this will be 1. So you can see that I have a new flat value, and the flat value attached to this is actually 2, and the source of this modifier value is muscle, right? Pretty cool. So if I go back to the game and attack a bat, I still do 6 damage. But let's end the turn for a second, take some damage, and you can see that my stacks go up to 4. So if we go back to the remote scene tree again, you can see that I still have just one modifier value under the damage.modifier, which is pretty cool because we said that if the source was already used, we just want to overwrite it. We don't want to create new nodes over and over again whenever we create a new modifier value with the same source again. But if you take a look at the member variables here, you can see that the source is still the muscle one, but the flat value actually increased to 4. Pretty cool. So now the modifier handler and the damage.modifier specifically has the amount of modifiers and tracks all the numbers we want to. But the problem is that the cards still don't use this, right? So even though we could be doing more damage, and we see that the system is working as intended because we had access to those numbers, we're still not actually doing damage this way. So that's what we'll address next. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Okay, so let's actually make these changes work when we play cards. But how do we do that? Let's think about this for a second because this is a pretty big refactor, right? So we're doing this from the player's perspective first. When do we need to take these modifications into consideration when it comes to the player? Well, for now, in this state of the game, we only care about these modifiers when we play cards, right? Because when I play cards like damage cards, for example, I might want to take my damage dealt modifier into consideration. Another example would be when I take damage, right? Because for whatever reason, I can take less or more damage based on the current modifiers I have. So let's not worry about that for now. Let's start with playing cards. That's the more interesting part, right? I have my muscle, which means I deal more damage. So how do we prepare playing cards for having access to these modifier values? One of our starting points can be the most basic script or the heart of the whole card system, which is the card resource itself. So let's press Ctrl-Alt-O and search for card.gd. If we take a look at card.gd and we scroll down to the methods, right? We have this is single targeted method. Well, that's not really relevant, right, to applying modifiers. We have that get targets method, which is concerned with the targets of the specific card. Again, not that relevant in this case. However, we have two methods here which are pretty important. One of them is called play, and the other one is called apply effects. So let's real quick recap what both of them do. So we call this play method when the card UI detects that we can play this card because we dragged it, it goes into the dragging state, then we release it, and it has valid targets, right? If it's single targeted, we have an enemy selected, and if it's not single targeted, then we can just drag it over the card area, and when we release it, it means we play it, right? And after playing the card, we end up calling this apply effects method either way. And this method is the one which we override for all specific cards, right? This is where we implement their logic. So for their logic, it would be pretty useful to have access to the player's modifiers, right? But in order to do that, we also need to have access to them here because this is where we call it, right? So the chain goes like this. We call this play method from the card UI class. So the card UI will need to have access to the player's modifier handler, so we can pass it on when we call this method. So when this method has access to the player's modifiers, then it can pass that modifier handler over to the apply effects method. And when that apply effects method's signature has two arguments, one for the targets and one for the player's modifier handler, this means that when we script all the specific cards, we now suddenly have access to the player's modifiers. So this is exactly what we'll be doing here. And from the perspective of this card class, it's pretty simple. We just need to change the method signature, but we also need to take care of that logic outside this class to make sure that we actually have this modifier passed on. So right now what we want to do is just say that we have a third parameter in the case of play, providing access to the modifiers. And in the case of the apply effects method, we'll have two parameters, one for the targets and one for the modifier handler. And you can sort of immediately see that we have these error messages because the apply effects method no longer expects one argument but two. So we can replace this with passing the modifiers as well in both cases. And now the error messages cease to exist. Awesome. So that's all we really need to do for the card.gd itself. However, we're far from finished here, right? Because whenever we call this method, we need to have a third parameter provided and it's not optional. Okay, so one thing we can do is we can search for this string like play and the parentheses to call this method with Ctrl-Shift-F. And if we find all the occurrences, well, outside the sound effects, of course, we'll see that in cardUI.gd we have a method here, right? And what do we do in cardUI.gd? We say that whenever this play method is called, when we release the cardUI in a proper position or with a proper target, we call card.play with pressing the targets and the character stats as arguments, right? And then we queue free or delete the cardUI itself. Awesome, but that's not gonna do it anymore, right? Because these are just two arguments or parameters and we expect three now. So if we scroll all the way up, the problem is the cardUI as of now doesn't have access to the player or the player's modifier handler. So this is what we need to change next. And again, we can fix this pretty easily, kind of, but then we have to think the whole thing through again. So we can just say something like, okay, I need a new export variable. I'll call this player modifiers. It comes from the outside world and I just need to have access to one player modifier or one modifier handler which belongs to the player, right? Cool. Now that I have this, I can just go back to that play method and say that instead of card.play with just two arguments, I say card.play and I just pass the player modifier's export variable as well. And mind you that I have this error message saying that there are too many arguments for the play call, but that's not true at all because if I go back to card.gd, you can see that I have three parameters here. So I found that this is just a bug with the editor. If we go to project and reload current project, the error message will indeed disappear. So we solved the problem, right? Well, yes, but no. Because if we scroll back, just because we created an export variable, it doesn't mean that this will be assigned, right? We still somehow need to provide access to those modifiers or to this modifier handler. So who's responsible for creating these cardUIs and showing them to the player? Well, the hand, right? So let's search for hand.gd and see if we can change something here to make sure that when we create a new cardUI, that cardUI will have access to the player's modifiers. And this is where the bug stops, kind of, because we can do something like creating an export variable for a player node, and this is fine because if you think about it in the battle scene, we always have a player character and we always have a hand, right? So we always have those two entities, so we can just say that, okay, we provide a reference to them. And then when we actually create a new card UI, then we can just inject that dependency and saying that the new card UI's player modifiers property, which we just created, will be equal to player.modifierHandler. And now we went all the way from the hand to the card UI here in the play method to the card.gd. And when we play it, we have access to this modifier. And when we call the apply effects method, which will be defined specifically for all the different cards in the game with their own logic, now we can actually use the modifiers. I hope it wasn't too confusing, but now we can actually make sure that all the attack cards use that muscle modifier we can have. So let's save all the scripts we changed with Ctrl+S, and now we can hop in and modify all the specific cards. But before we do that, actually press Ctrl+O and search for card template.gd. Why? Well, if you remember, we wanted to provide like this template script. So when we create a new card, we always have the method name given for us and some like example code how we can go about creating and scripting a new card. Right. See, the problem is the signature no longer matches the parent because this template extends from the card class. And in the card class, the apply effects method no longer requires just one parameter, it requires two. So in card template.gd, we need to fix the signature as well. So we can say that we have a targets array, but we also have a modifier handler, which we can call underscore modifiers for now, because it's not used in this example. Cool. So now we fix the template too. So whenever we create a new card, after this big refactor, we made sure that it has access to the player's modifier as well, and it matches the signature of the parent class to card.gd. So what about the cards themselves? So let's press Ctrl-Alt-O and search for all the cards beginning with warrior underscore. So let's fix them one by one. Let's see warrior block first. Okay, so for warrior block, we don't really need to do much because block won't be affected by the damage dealt modifier, which we want to test right now, but we need to make sure that the signature matches the parent. So again, we can just use underscore modifiers and say that for now we don't actually use the modifier handler, we just block for 5 and that's it. If you want to, you can create modifiers in your game for block as well. So besides the damage dealt modifier, you can do something like block gain modifier. And then you have a modifier. Then you can have a status like dexterity in Slay the Spire, which increases the amount of block you gain. For keeping the scope reasonable, I haven't included this in the tutorial, but it's a nice exercise you can do for yourself. For now, the block just needs this to make sure that the signature matches, and we can save it with Ctrl-S. Now let's press Ctrl-Alt-O and search for warrior underscore again, and let's tackle the slash this time, which is the AoE attack. So here, what do we do? Well, first we need to make sure that the signature matches the parents, right? We have the targets and we have the modifiers. Then, instead of setting the damage amount to just simply 4, first of all, we can extract this value to be a member variable, so it's easier to change later when we design a game. We can say something like var base damage should be equal to 4. And here, instead of 4, what we do is we say modifiers dot get modified value, and the base damage will be the base damage variable. And the modifier we need to use for this specific case when we want to modify the attack damage we do will be modifier.type.damage dealt. And that's it. That's the magic. The modifier handler attached to the player will take care of like summarizing or calculating the whole end result by taking all the flat modifications and all the percent based modifications under the damage dealt modifier, right? Pretty cool. And that's all we need to do really. So we'll kind of do the same thing for all the attacks. So right now I just copy this expression here and save this with Ctrl-S. And we can search for the next one, warrior underscore big slam. Again, the signature needs to match the parent. So for the damage effect, instead of dealing the base damage, we can paste the same expression. We even call this variable base damage too. And let's not forget to fix the signature, saying that we'll have modifiers, which is a modifier handler. And that's it. We can save this with Ctrl-S. Move on to the next one, which will be warrior underscore X attack. And this is the base attack we have in the game. Again, we can do the same. Instead of saying 6, we can create a new variable here called base damage. This will be 6. And we can replace this when we have access to our modifiers. So again, we'll have a modifier handler as a second argument like we always do, and say that we'll have modifiers that get modified value to modify the base damage by the modifier type of damage dealt we have. Right, save this with Ctrl-S. And the last one we have is through strength. And since this is a power card applying a status effect, we don't really have to do much. We just need to make sure, just like we did with the block, that the signature matches. So again, we'll have a modifier handler. And in this case, to avoid this argument saying that modifiers is an unused parameter, which is absolutely true, we don't use it. In this case, we can use underscore modifiers to indicate that this is unused. Right. So we can save this with Ctrl-S, and these are all the modifications we need to do in order to test this new modifier system in action. However, there's just one last thing we need to do. If you remember, we had this whole line of communication like arriving there, right? So we have the hand will have access to the player, and when it spawns a new card UI, it sets the card UI's player modifier's property to the player's modifier handler. So in the card UI, we have this new export variable called player modifiers, and when we call the play method, we call the card resources play method with 3 parameters now. So if we go to card.gd, we indeed have 3 parameters here. And when we apply the effects of a card, then we have these modifiers as a second parameter. Cool. So the chain looks intact. Again, we have a warning message here because I forgot to add the underscore here. Right. See, there's one little thing that we mustn't forget, and that's actually creating the connection between the player and the hand, so we can start passing on the modifier handler and injecting that dependency. Where do we need to do this? Where do we have the player and the hand present? Well, in the battle, yeah? So let's go back to 2D view, press Ctrl-Shift-O, and search for battle.tscn. And I'm kind of annoyed by all these scenes open here, so just to tidy things up a bit, I press my scroll wheel on the mouse to close them. And now I only have the run and the battle scenes open. And if we click on the hand in the battle scene, you can indeed see that we have this new player export variable here. And it says that we can assign it, right? So this is the connection we need to establish between the hand and the player, so the card UIs can have access to those modifiers. So let's click on assign and select the player in the scene tree. Right, so this is really important. So without this, it wouldn't work. This is the connection we need to establish to make sure that we can pass that modifier handler to all nodes that need it. Now if we save this and play the game, we have a super weird error message saying that when we try to add a card or draw a card, we have nil. So I'm assuming that it has something to do with changing the whole card ecosystem in our game, but let's investigate. So if I go under characters and warrior, we have the cards here, right? All the icons and all that stuff still looks just fine. So the cards can be the culprit, right? What about the warrior character itself? We still see that it has a starting deck and the draftable cards array. Awesome. So what about the starting deck? Okay. So it seems that just because I restarted my editor for whatever reason, it seems like both of these resources ended up resetting and both of those arrays are empty. So let's just sort of refill them, because you might encounter this error again. I didn't when I was preparing to record this video, but it just shows you that sometimes these things can happen. So again, just rebuild that sort of deck we had earlier. Let's say we have 4 attack cards, 4 block cards. So we have a slash, we have the true strength, and we also have the big slam card ones. And we can just sort of drag those over. Maybe we can have 2 AoE attacks like so. Okay, so this is our starting deck rebuilt. And what about the draftable cards? Okay, so we can, let's say we can draft 10 cards as well. And if I remember correctly, we said that we can include the same cards multiple times to make sure that the whole system works. And we also have the slash we can get, right? Like so. Okay. So we rebuilt both the draftable cards and the starting deck, which again, for whatever weird reason, what my guess is what happened is when we changed card.gd, right? We changed the signature of this method. And when we changed that and we reloaded the project and made sure that in card UI, this error message, which wrongly said that it expects 2 arguments, changes to 3, we had to reload the project, right? So I guess when we did that, all of the card codes we changed, like warrior slash, right? We changed those because they still didn't have those modifiers. And in a sense, they were invalid, right? At that point in time, they were invalid, right? They were attached to those resources, but they were invalid as they had syntax errors. So I think for some reason, this made these resources like corrupt or something, and they reset it to an empty array of cards to make sure that they can be valid resources. So this is just a guess. But anyway, we figured out what the problem was. And now we can run the game again. Yeah. So you can see that the error no longer occurs. And it's perfect because I draw my power card on the first turn. And if I end my turn here, okay, cool. So I have 2 muscle stacks right here, right? And if you go to remove scene tree again, we can go under battle, player, ModifierHandler, and you can see that for the damage dealt modifier, we have 1 modifier value, which adds 2 flat value, right? So now in theory, all my attack cards should deal 2 more damage. So this attack does 4 damage to all the enemies. And you can see that the tooltip still says 4, but it doesn't really matter. We'll change the tooltips later. Now if I just play this, did you see that? It indeed dealt 6 damage. Pretty cool. So if I end my turn here, the crab gains a ton of block, and my muscle stacks go up to 4. And you can see it in the background as well. I still have my damage modifier value note here, and it says a flat value of 4 now. So if we take a look at my basic attack, which deals 6 damage, in theory, it should deal 10 now. So if I drag this over to the enemy, you can see that it subtracts 10 block from the enemy. How cool. So if I play this card again, this should deal 8. And if I use this one, the crab has 9 HP in total. So in theory, I could kill him. Absolutely fantastic. Right. So the system works properly now. We established that long chain from the hand all the way to the specific cards. And now we can have access to all the different modifiers we have in the game. How cool is that system? And just to show you that the whole thing works perfectly fine, we can open up the player scene again. So press Ctrl-Shift-O and search for the player. And we can just arbitrarily add a damage dealt modifier value ourselves. So if we instantiate a new one and add the modifier value under this, we can say that we have like Ascension in Slay the Spire, and we can say that in harder difficulties, we start with like negative percentage value and say that we deal, it's really harsh, but we deal 50% less damage, right? So it's a percent-based value, and the percent value will be negative 0.5. Right, if we save the scene and run the game and go into battle, we have that modifier right away. I drew my power card on the first turn, so let's play this just so I can show you how the whole thing's calculated and that it stacks. Right. So how much damage do I do? I have this card here, which deals 6 damage by default, right? Because I have 2 stacks of muscle, I applied a flat 2 value to it, so 6 plus 2 is 8. But let's not forget that I added that negative 0.5% base modifier, which in theory means that I should do 4 damage, right? If we go to the remote scene tree, again, just to make sure that it works, we have our player, we have our modifier handler, and now I have 2 nodes here. One with negative 0.5 and one with 2 as a flat value. And see, the order doesn't really matter here. So it won't be 6 and the half of 6 is 3 and the flat value is at 3 plus 2 is 5. So it won't be 5 because the way the algorithm works is we apply all the flat ones first and then the percentage modifiers. So in this case, it will be 6 plus 2 is 8 divided by 2, meaning taking the 50% of it will be 4. So if I play this, indeed I deal 4 damage, right? So everything works as intended. My muscle keeps stacking, and you can see that this is the one we override. The other one remains the same because the source doesn't match, right? So we want to mess with the muscle when we increase the muscle. So now instead of 4 damage, this should deal 10, but because of the 50% negative modifier, this should be 5, right? This will be 4. 4 plus 4 is 8, and the half of this is 4. So it kills both enemies. So I just wanted to show you that you can indeed stack those modifier values, which gives a pretty great flexibility because you can stack all these different statuses and relics and card effects on top of each other, applying different modifiers to the game. Pretty awesome. So we can delete this sort of temporary modifier. I just wanted to sort of demonstrate this and save the player scene. And we start setting up all the stuff for the enemies next. Okay, with the player out of the way, let's hook up the enemies next. So press Ctrl-Shift-O and search for enemy.tscn. Here we kind of need to do the same thing we did for the player. Prepping in the inspector is pretty easy. Let's select the enemy node, the root node, and click on the Instantiate Child Scene button or press Ctrl-Shift-A. And let's add the ModifierHandler first as the very top level node. Under the ModifierHandler, click on the Instantiate button again, and this time add modifiers to it. So we'll add one modifier and we'll duplicate this once. For this example project, I'll only use 2 modifiers for the enemies. One of them will be called damage dealt modifier, just like with the player, and the other one will be damage taken modifier. For the enemies, adding a card cost modifier makes no sense, so we are perfectly fine with just these 2. And for the damage taken modifier, make sure to set the type to damage taken instead of damage dealt. But for damage dealt type is perfectly fine. And that's all we need from the inspector side, so we can save this with Ctrl-S and go into the enemy script and see what we need to change here. Right. So here what we do is, again, pretty similar to what we did with the player. From the perspective of the enemy, the only thing we really need to do is to provide an onReady variable access to the modifier handler so we can reference it whenever we want to. That's it really. We can save this with Ctrl-S and see how we can replace the placeholder code for the exposed status, which we can do with our big slam attack. And according to the exposed status, we should do 50% more damage to targets with the exposed status. In other words, it means that all entities which have the exposed status should take 50% more damage, right? So let's press Ctrl-Alt-O and search for exposed.gd. And you can see that we only have placeholder code here for now. And what we do is we sort of create a debug print message, and as a placeholder thing, we just sort of created the damage effect and make sure that the target with the exposed status takes 12 damage at the end or the start of their turn. So how do we replace this? We actually don't really want to do anything when we apply the status, but we want to do 2 things. We want to initialize the status. So when the exposed status is established, we want to create a modifier for it, right? And the other thing we want to do is when that status expires, right? When the duration reaches 0, we want to remove that modifier. We want to delete it. So we can actually delete all of this code. And instead we'll have 2 methods. First of all, we'll override the initialize status one, which we provided in the base status class. And what we do here is pretty similar to what we did with the muscle. So we have an assertion here saying that the target should have a modifier handler. If it doesn't, then we raise an error. Then we grab a reference to the damage taken modifier this time. And again, we make an assertion saying that if they don't have, for whatever reason, a damage taken modifier, we should raise an error. And after having that access to the damage taken modifier itself, we'll sort of query that damage taken modifier and see if we already have our exposed modifier value established or not. If not, then we create the new exposed modifier value using the static function of the modifier value class. We create it as a percentage based, identified by the source of exposed. we set the percent value of it to the constant modifier we have in our status, and we add it as a new value to the damage taken modifier, right? And the reason why we do this in the initialize status callback, because we only want to do it once, right? If you think about it, we hit the crab with the attack, then we immediately want to apply this modifier. And that modifier actually stays there, and we don't have to do anything with it up until the point where the exposed status expires. So the final thing we need to do once is to actually connect the status changed signal to our own status changed callback. And in this case, we could have bound the target again, the player or the enemy, to that callback function. But since we already have access to the damage taken modifier, which is the one we care about here, we can bind directly that modifier instead. So what do we do in this callback function? Well, it's pretty simple. We have access to the damage taken modifier, and whenever the status changes, we ask if the duration is less than or equal to 0, meaning that the status is about to expire or already expired. And if that's the case, and we have a valid damage taken modifier available, we want to remove the value which is identified by the exposed source, right? Because this means that if the crab is still alive, the exposed expires, so we no longer want to apply or take that extra 50% damage. So we can call the modifier's remove value method to do this. Pretty straightforward, right? Again, you can see how we can take advantage of that flexible modifier system in a completely different context to the damage dealt modifier we had for the muscle. Right, so we can save this with Control S. You could say that, cool, then we're ready to test this, right? Well, sure, why not? Let's test this. If we run the game, we should be able to play our blue card, which applies the exposed status effect, like so. Okay, so clearly the crab has the exposed status effect. What does that mean? If we go back to the project and go to the remote scene tree, under the enemy handler, we'll have our enemy, and that enemy indeed has the modifier handler. And under damage taken, we have a value here, right? It says that it has a percent value of 0.5. The source is exposed. Awesome. But I don't want to play this card right now because that would kill the crab. But if I go to the next turn, you can see that I still have that modifier. But when I do damage to the crab, I still just do 6 damage. Why? That's the big question. I have that modifier value here, right? It should work. So if I end my turn here, you can see that the exposed status expired and the deletion works as well, because the damage taken modifier under the crab no longer has any children attached to it. So we no longer have access to that 50% modifier. And if I use my AoE card here, it deals 4 damage like it did before. So it kind of works, but at the same time, it doesn't. Why is that? That's the question. Well, even though we set up the modifier just like we need to, if we go back to the enemy script, and maybe my script list is getting out of control here, so I can right click on this and say close other tabs. If we go back to the enemy script, what happens when we damage an enemy? How do we damage an enemy at all? So if we take a look at our X attack card, for example, that's a way to deal damage, right? What happens is we create a new damage effect. Okay, so how does a damage effect work? If I press and hold Control and click on this, you can see what a damage effect does. It calls the target's take damage method with the amount of damage we want to cause. Okay, so the target is, in the case of the crab, is an enemy, right? So the enemy script, enemy.gd, has a method called take damage. And the take damage method receives that 6 damage or whatever the amount is. And with this tween, we call the stats resources take damage method, which subtracts the health. See, that's the problem. Even though we have everything set up in the modifier handler's damage taken modifier, we actually don't use it anywhere in the code. right? So for the damage taken modifiers to work, we need to sort of rethink the way we take damage, both with the player and with the enemy. Because right now, if we say that we take 6 damage, it will just be 6. So we need to change this take damage method both for the enemy and for the player. The question is, how do we do this? So what do we really need to change here? We can do something like creating a new modified damage variable and say that for the enemy, we grab the modifier handler and get the modified value for the damage we were about to take, but apply all the modifications for the damage taken modifier. And yes, this works. And then all that's left to do for us is to copy the name of this variable. And instead of using the original damage, which is the parameter of this function, we just pass the modified damage to the stats. And this actually works. So if we save this and run the game again, start a battle, and hopefully I can draw my card next turn. Awesome. So if I play this, then the crab enemy will be exposed for 2 turns. And you can see that the exposed status is still applied. So in theory, if I use my card now, which deals 6 damage by default, and you can see that I have no buffs, right? So this will be 6 no matter what, because the player who initiates the attack doesn't have any damage dealt modifiers. However, on the other side of the coin, the enemy still has 1 exposed, which means that it has a damage taken modifier with 50% added. So it should take 9 damage. And it does. Awesome. So it goes from 15 block to 6. Perfect. But if I end my turn here, the exposed status expires. And if I play my attack card again, now I only deal 6 damage again. Everything's fine, right? We solved the problem. Well, kind of. So this is a pretty easy solution to the problem. And right now it's a perfectly fine solution. But let's just peek into the future a bit, if you will. So the problem with this solution when taking damage is that in the future, we'll introduce relics to the game, right? And there might be relics, like we'll have a relic called Explosive Barrel, and Explosive Barrel deals 4 damage to all enemies at the end of the turn. Cool, right? See, the problem with this implementation is whenever I call this take damage method, the damage taken modifiers will always be applied. And that's a problem. Because I want this damage taken modifier, for example, in the case of exposed, to only work when the player plays attacks. So for example, in Slay Spire, when the target is vulnerable, if you play potions or your relics deal damage to them, then they won't take increased damage because they're vulnerable, right? That only applies when you play attacks against them. But the problem is right now, our code can't handle that. Because whenever I call this take damage method, this damage taken modifier will always be applied no matter what. Hopefully you see what's the problem with that, right? So in the case of this take damage method, we actually need to make it a bit more flexible. Instead of saying that we always apply the damage taken modifier, we can say that we actually need a second argument whenever we want this entity to take damage, and we can specify which modifier we want to apply. And this makes a big change, even though it might seem like a minor thing. So instead of getting the modified value for the damage taken every time, I can just replace this with the parameter which modifier. And so the cool thing about this is if you take a look at what kind of modifiers are available to us, we have damage dealt, damage taken, card cost, shop cost, etc. And we have this one, no modifier. So what we can do in the case of relics or potions or whatever it is we want to add to the game, we can say that when we call this method, that we want to use the no modifier when we apply the damage. And in this case, probably neither the enemy nor the player will have a no modifier attached to them, because that makes no sense, right? And that's perfect, because when we have no modifier, then what this method does, this get modified value, is just returns the base damage. And that's perfect, because that's exactly what I want for the explosive barrel. I don't want any kind of modification attached to that value. So I can say that I call this take damage method, it will do 4 damage, and for the modifier we will apply a no modifier type of modifier, So this will be the same as the base damage we passed in as a parameter. I hope that makes sense. So in this case, this small change makes the whole solution more flexible, and we can create things or damage sources which are unaltered by other means of modifiers. For example, the damage taken modifier. Cool. So we want to do the same thing for the player, right? Because the player can have exposed or vulnerable or however we want to call this. So let's press Ctrl+Alt+O and search for the player as well. And the player has the take damage method too. And we kind of want to do the same thing. So we'll provide a modified damage variable, and we'll use that modified damage variable when the tween actually calls the resource to subtract that damage from the health. And for this to work, again, we need a custom specifier type to let the take damage method know which kind of specifier we want to use for this. So again, the changes we made, a second argument which is required for this method. Then we get and store the modified value for the base damage for that specific modifier. And finally, when we call the take damage method for the stats, we bind that modified damage as a parameter. So we can save both of those scripts with Ctrl+S. And we sort of have the same problem we had when we refactored the cards. We made the change for the take damage methods, both in the player and in the enemy scripts. But actually, when we call those, they still receive just one parameter. So let's just select this take damage into parentheses and press Ctrl+Shift+F and search for take damage to see where we call this method, right? And if we try to scroll between the matches, we see that we don't have really much, especially because most of those are from stats, character stats, player or enemy. And these are the methods we already sort of established. We only have one place where we use this, and that's the damage effect.gd script. And here what we do is we create a damage effect. And if the target is an enemy or a player, we call the take damage method with the amount of damage we want to deal. Perfectly fine. Or at least it was before. But now we can simply fix this to have two parameters passed, right? Or two arguments. Only thing we need to do is to create a new member variable, and we call this receiver modifier type, which by default will be the damage taken, right? Because in most cases, when we create a damage effect, we want to apply the damage taken modifiers, right? And under take damage, next to the amount, we have to provide the second argument, which will be receiver modifier type. And with this little change, if we save this, now we're good to go. And the thing here is we can still use the damage effect for the explosive barrel relic in the future. Why? Well, because whenever we create a damage effect, we can replace these member variables, right? So we can just say that the amount will be 4 and the receiver modifier type will be type.noModifier instead of damage taken. So we made both the damage effect super flexible and reusable, and the take damage method too. Because we can use the same take damage method in combination with the damage effect to create relics, to create cards, to create status effects, or whatever it is we want to create. Pretty cool. Now we just need to test this, right? So with all scripts saved, one thing we can do is we can go back to 2D view and search for the crab enemies resource. And we have crab enemy.tres. And we can change the max health to something bigger, like 25, to make sure we can test all the things we've implemented so far. And to kind of see if the same exposed thing works on the player as well, we can go back to the player scene and go to the script. And in the ready callback, we can do something like this. We create a new exposed resource, set the duration to 3, and add it as a status to ourselves. This is kind of counterintuitive in terms of gameplay, but with this, we can test if the exposed works both on us when we receive damage and both on the enemy when they do. So with this piece of little testing code, we can run the game again. And if we go to a battle, we encounter our crab enemy, right? So let's play the power to see if things stack and work properly next to each other. So this crab wants to deal 7 damage, but remember I do have the exposed status, so in theory I should take 10.5, which is floored to 10, right? And indeed, when the crab damages me, I take 10 damage. Awesome. So if I play my attack card here, I have 6 damage by default, but I have 2 muscle as well. So I should do 8 damage to the crab, and I do. It becomes 17. Awesome. And in the next turn, it has 6 block and 17 HP, right? I have 4 muscle. So if I play this card and apply the exposed, this deals 4 damage. So 4 plus 4 should be 8. And indeed, it goes to 15. And now what happens is I should be able to precisely one-shot this enemy, right? Let's do the math here. I have 6 damage and 4 muscle. 6 plus 4 is 10. So I'll have 10 base damage, but the enemy has the exposed status, which means it takes 50% more, and 10 plus 5 should be 15, right? So in theory, if everything's working properly, I can one-shot this crab. And indeed I do. Perfect. How cool is that? With the status system and the modifier system in place, you can do some pretty awesome stuff with cool combinations, cool status effects, and all sorts of modifiers in your game. Right, so that's the kind of the hard part done, but at the same time we still have a lot of work to do because, well, the tooltip system and the enemy intents are all messed up now, right? Because if you take a look at this one, I did 15 damage, but it still said I'll deal 6. And that's not really good from a UX perspective because we want to always tell the player what playing that card will do, right? The next big thing will be to actually implement all the changes first to the card tooltip system, then to the enemy intent system as well. And when we're finished with those refactors, or those changes to making them more dynamic by using magic numbers, then we can actually move on to status tooltips because right now we only have these little icons here and you're not always sure what these status effects do. So you see the X mark and the 2 next to it for the exposed, but you don't really have a way to tell the player what that means really. So we want to implement a tooltip system as well. So this is what we'll do next. But before we do that, we can actually get rid of this temporary code in the player script, which was just to test how everything works. And for now, I'll leave the crab enemy at 25 HP, but if you want to, you can revert the changes to the crab enemy as well. So the next thing will be to fix those issues and then implement the status tooltip. However, I feel like this episode is pretty long already, and this is kind of a natural point to cut it in half. So we'll fix all of those issues in the next video, and that's it for this one. I'll see you in the next one. Bye-bye.